Okay, here we go. Another video. Welcome back. So I am going through the write unit test tutorial, which is Unit 1, Pathway 4, Lesson 5. So Android Basics in Kotlin, Kotlin Basics. So Unit 1, Pathway 4, Lesson 5. All right, let's check out write unit test. Take a look. Code Labs. Before you begin, in previous code labs, you learned how to create a project with Android Studio, modify XML to make a customized user interface for your app, and modify business logic to add functionality. This code lab focuses on why testing is important and expands upon unit tests. You get the opportunity to see what they look like and how to write them. Prerequisites. You have created a project in Android Studio and you have experience writing code in Android Studio. What you learn, why testing is important, what unit testing looks like, and how to write and run unit tests. What you'll need, a computer with Android Studio installed, a project you created in the previous code lab in this pathway. Next. Introduction. Now that you've written some Android code, it's a great time to follow up with some test code. First, you'll go over some philosophy on testing, then dive deeper into the auto-generated tests in an Android project. And lastly, you write your own test for the Dice Roller app. This covers a lot of material, but don't be intimidated. Take your time with the material because testing takes a long time and a lot of practice to learn. Don't be discouraged if you don't get a handle on it right away. Why testing is important. At first, it might seem like you don't really need tests in your app. When your app is small and has limited functionality, it is easy to test manually and determine if everything is working correctly. However, as your app grows, manual testing takes much more effort than writing automated tests. Furthermore, once you start working on professional level apps, testing becomes critical when you have a large user base. You must account for many different types of devices running many different versions of Android. Eventually, you reach a point where automated tests can account for the majority of usage scenarios significantly faster than manual tests. When you run the tests before you release your new code, you can make changes to the existing code so that you avoid the release of an app with unexpected behaviors. Remember that automated tests are tests executed through software as opposed to manual tests, which are carried out by a person who directly interacts with the device. Automated testing and manual testing play a critical role in ensuring that users of your product have a pleasant experience. However, automated tests can be more precise and they optimize your team's productivity because a person isn't required to run them and they can be executed much faster than your manual tests. A closer look at unit tests. In this code lab, you'll focus on unit tests. You cover instrumentation tests later on. To start, you look at the tests that are generated when you create an Android app through Android Studio. You also get some hands-on experience running the tests and gaining some familiarity with writing code. In a previous pathway, you went over where to find the source files for tests. Unit tests are always located in the test directory. Okay. So com.example.diceroller test example unit tests. And they're in the same Java folder as your main activity KT. All right. Or .kotlin. Open the app/build Gradle file and look at the dependencies. You'll see some dependencies marked as test implementation and Android test implementation, which correspond to the unit and instrumentation test respectively. So we'll open our last app, Dice Roller app, and we'll take a look at the project. And we'll take a look at, close the resources folder. Okay. Build.gradle. All right. And it said to look app build.gradle. Okay. And look at test implementation. All right. So Dependencies, test implementation. JUnit 4.13.2. Implementation, all these are implemented too. Okay. Yep. The JUnit library is the one that drives your unit tests and lets you mark code as a test so that it can be compiled and run in such a way that it can test the app code. In the test directory, open the example unit test KT file. You should see a sample unit test that looks like this. Okay, let me take a look. Test. Okay. Unit test. Example unit test. Okay. Mine doesn't look exactly like theirs looks, but it's close. Okay. Class example unit test at annotation test function addition is equal correct. Assert equals 4. 2 plus 2 is 4. Okay. Yeah. So example unit test, annotation test function addition is correct. Assert equals expected is 4. Actual is 2 plus 2. All right. While you added some code to the Dice Roller app, you likely didn't write any test, as such, there's nothing but some generic code that created automatically by Android Studio. This is an arbitrary test that serves as a placeholder for more relevant tests that a developer is expected to write. Currently, this block of code only tests that 2 plus 2 equals 4. Of course, this is always true. Take a closer look at what's happening. Test functions must first be annotated with the @ symbol, and then test annotation imported from the org.junit.test library. You can think of annotation as meta tags for a piece of code that can change the way the code is compiled. In this test, the @test annotation lets the compiler know that the following method is a test which lets it run as such. Following the annotation, you have a function declaration. In this case, the addition is correct function. Inside the function, the assert equals function asserts that an expected value should equal an actual activity obtained through business logic. Assertion methods are the end goal of a unit test. Ultimately, you want to assert that a result obtained from your code is a particular state. If the state of the result matches the expected state, the test passes. If the state of the result does not match the expected state, the test fails. In this case, the code is actually comparing two values. So the assert equals method takes two parameters, an expected value and the actual value. True to its name, the expected value is what you would expect the particular result to be, in this case 4. The actual value represents the result of an actual piece of code. Generally, this would test a piece of code from the app itself. In this case, it's only an arbitrary piece of code, for example, 2 plus 2. Without further ado, run a test to see what happens. Note, there are many assertions in the JUnit library. Some common assertions you might encounter are assert equals, assert not equals, assert that, assert true, assert false, assert null, assert non-null. For more information, see assert. There are many ways to run tests in the Android Studio, which you dive into later. Now you keep it simple. Next to the addition is correct method declaration, click the arrows and select Run. Okay. Run example unit test. Okay. It opens up a dialog box. Starting. Instantiating tests. Test pass 1 of 1. Okay. This is what is referred to as a positive test. In other words, the assertion is in the affirmative or affirmation. Okay. 2 plus 2 is equal to 4. Alternatively, we could write a negative test which makes an assertion in the negative. For example, 2 plus 2 is not equal to 4. In the run pane, you should see something like this screenshot. Test results, check, test pass 1 of 1. I did. Okay. There are various indications that the test succeeded, namely the green checks and the number of tests that were passed. Modify the test to see what a failure looks like. Change 2 plus 2 to 2 plus 3 and then execute the code again. All right. 2 plus 3. What did I do? Whoa. I didn't mean to select that. Stop and rerun. Okay. Starting. And now it should not equal 4, so the test should fail. Let's see what happens. Yeah. Okay. Start a Gradle. Expected. All right. Test debug, unit test failed. Expected a 4, but it was 5. Click to see the difference. All right. After you run the test, you should see something like this. I do. The red text indicates a test failure. In the menu of the test results, clicking on the items in the provides an error message that indicates why the test failed. Yep. Okay. So if I just click on it, it'll bring me right to it. Let's see. Yep. Okay. All right. In this case, the message indicates the assertion failed because the expected result was 4 and the actual value was 5. This makes sense because you changed an actual value to be 2 plus 3, but left the expected value as 4. All right, for the sake of thoroughness, change the expected value from 4 to 5 and run it again and see if it passes. Okay. All right, and it passed. All right, next. Write your first unit test. Now that you've gained some comfortability with unit tests, you can write your own unit tests that are more relevant to the Dice Roller app. Okay, as you've already noticed, the Dice Roller app's primary functionality is based on a random number generator. Unfortunately, random number generators are notoriously difficult to test because you can't be sure of the outcome of a randomly generated number. The goal of this test is to ensure that when you roll the dice or call the roll method on the dice class, you get an appropriate number back. To test this, you simply write the test you write simply tests the output of the random number generator and is a number within the range that you specified to the generator. In the example unit test, delete the file generated test method and import statements. Your file should now look like this. So I'll delete the Alright, so it wants me to keep the class example unit tests in the package, but delete the imports. So I will delete addition is fun. We'll keep the unit tests. Imports. Wants me to delete the imports. Okay. Alright. And it's not going to be an example anymore because we're going to do a real test. So let's see. Create a generates number function in the example unit test.kt. Annotate generates number with @test. Okay. So @test. Generates number. Okay. When you try to call @test, the test is in red. This is because it can't find the declaration of this annotation, so you need to import it. You can automatically do this when you press Control Enter or Options plus Return. I think I have it set to just automatically import stuff. Yeah, it automatically imported that for me when I typed it. Okay. Alternatively, you can also copy and paste the import or JUnit test file after the package name but before the class declaration. So after the package name but before the class declaration. Code should now look like this. It does. Okay. Create an instance of the dice object. All right, val dice equals dice. 6. Next, call the roll method on this instance and return the value. Val roll method equals dice roll. And store the returned value. Okay. In roll result. Okay. Dice equals dice 6. Roll result. Dice dot roll. Okay. So here's our object. We're going to give it 6 sides. And then we're going to do roll another value now. Roll result. We're going to set it equal to dice dot roll. Okay. Finally, make an actual assertion. In other words, you need to assert that the method returned a value that's within the number of slides that you passed in. Sides that you passed in. So in this case, the value needs to be greater than 0 and less than 7. To accomplish this, use the assert true method. Notice that when you try to call the assert true method, the text is in red at first. This is because it can't find the declaration of this method, so you need to import it, similar to what you encountered with the annotation. assert true. Can automatically import it as previously discussed. Notice, however, at this time you have multiple options to choose from. So in this case, it should be the option from org.junit.assert package. Okay. Okay. So not the frameworks, this one. Okay. And now what? Assert true. Still true. Oh, I need to give it something. That's why. So, alternatively, you can copy and paste the import statement for the after the annotation. Okay. So your code now looks like this, and it does. If you put a cursor between the parentheses and press Control P, your tooltip shows you what parameter methods it takes. It's going to take a string. It's going to take a condition. Okay. The assert true method takes two parameters, a string and a boolean. So that's the top one. If the assertion fails, the string is a message that displays in the console. The boolean is a conditional statement. Set the message to. The value of roll result was not between 1 and 6. So that's why I set the string to. The value of the roll result was not between 1 and 6. As mentioned earlier, testing random numbers is a challenge because the value of the number can't be predicted due to the nature of its randomness. All that can be done is to ensure that the value is within a particular range. Set the condition parameter to roll result in 1.6. The code should now look like this. Assert true, roll result in 1 to 6. All right, let's do that. Paste. The value of the roll result was not between 1 and 6. Roll result in 1.6. So it is roll result is less than or equal to 1 or greater than or equal to 6. We'll put that in for us. Okay. Click the arrow next to the function and then select Run Example Unit Tests Generates Number. If your code looks like the previous code, that your test should pass. Okay, run. Test passed. All right, cool. Optional. For extra practice, modify the dice to be 4 or 5-sided without changing the assertion to see if the test failed. So basically just change the number of sides and see if it fails. So we had put that the number of sides was 6. Let's make it 4. Passed in this instance, but we don't know what it gave it. So let's run it a few times. It should still work actually every time. Because now instead of generating a number 1 to 6, it's only generating a number 1 to 4. And 1 to 4 is within 1 to 6. Okay. You learned the importance of testing, what a unit test looks like, how to run a unit test, and some common testing syntax and how to write a unit test. All right. All right, so we just finished the write a unit test section. So I'm going to end this video here, and I will see you in the next video.